Hey there, and welcome to Into the Terminal, episode 18. I'm Eric, the IT guy Hendricks, and joining me today is Scott McBrien.
Good morning, Eric.
Morning. So the last few days, we have been diving in deep to different tools, different commands, trying to kind of flesh out our sysadmin toolkit. Today, probably one of the most complex and crazy but powerful tools that we can add is automation. And that automation is through shell scripting. So today we're going to start out writing a very basic shell script in the critical path, and then in the second part of the episode we're going to make an interactive script that's going to ask users about what information they'd like to share, and we're going to have a script do a certain thing based on that response. So why don't we start out with how do we write a shell script? So for the most
So
part, you want to go ahead.
I was just going to say, it's important to note that a shell script is simply a collection of commands that should be executed in order.
That's a great point. And as we're going to create a shell script, why don't we write? We can do a VI or a vim on. We can give it a brilliant name like my script or something along those lines, and then we're going to use the .sh extension, and that's short for shell. So if we go ahead and VI, and then in VI you need to use the I key to enter insert mode, which is what allows us to actually type into the console or into the file we just created. So when we start, we need to define what shell that we're going to use for our script. In this case, we're going to use bin bash. A lot of times, it's good practice to get into on the second line of your script file to put in some kind of a comment, something that tells both yourself, your future self, or other admins who wrote it, what the purpose of the script is, any documentation you might have cited, maybe a last edited date, just different information. And you can do that by appending, by starting each line with an ampersand or the pound sign, or to some of the younger generations, the hashtag. So whatever you want to call that, the tic-tac-toe box, that tells the interpreter to ignore this line of text. That it's called a comment. So it's good to put some information like that into our text file. So we've got our shell, we've got a comment telling us what this file is, who wrote it, other information. So let's start out very, very simply here, and let's do an echo command. The echo basically takes the output of a command or just text that we put inside of quotation marks and prints it to the screen. As we mentioned yesterday, echo actually by default posts text to standard output. So if we run the script, we'll actually see that it will print the words "the time is currently." So next, let's use the date command, and that'll give us the time and date currently. Scott, what else should we have our script do?
Oh, why don't we have it just give some system information? So we've used IOStat a couple times, and maybe your favorite, 3-H, to look at the used memory.
I used -H the other day instead of -G. I was proud of myself. So this gives us a good output. This is kind of the foundation of some basic information of time and date and the actual health of our system. So this might be good to run when you first log into a box, just to get a feeling for what's going on. So when you're using VI in insert mode, you have to use the escape key to leave insert mode, and then you use a colon to define that you're going to give them a command, and then we're going to write the file, and then we're going to quit the file. That's what the :WQ means. You can also use :X to do a save and quit. It's the same thing, one less keystroke because I'm lazy. So let's go ahead and write and close out our file. Now I should just be able to run this command, right, Scott?
I mean, we could try, but I think it would fail.
Actually, let's do it. Let's run our script as is. Let's see what the output is.
Well, notice my tab completion won't even find it.
Mm-hmm. So, in order to fix that, what we need to do is if you look back to, I think it was episode 2 when we talked about file permissions, notice that there's no X in our file permissions. So, there's no execute permissions on this file. So, let's go ahead and do a chmod to change mode, and let's do, an A plus X works. And now tab completion worked. So now if we do an ls-l, you notice that the color changed and our user group and other permissions now have execute. So then, harkening back to that file permissions episode, we can actually execute, which, in other words, we can actually run the script now. So if we type my script into into the command line, notice that it's still not working.
It is not.
So you might have to do a period / and then my script.
That'll work, and we'll actually cover that in the deeper dive, I think. There we go.
So notice that it says that the current time is, and then gives us the date and time. We've got our IO stat output telling us about CPU and disk performance, and then there at the bottom gives us our free memory information. So that, in just a few minutes, is a basic example of a script file. And for the most part, when you start writing shell scripts, that's as simple as they'll be. And you'll see it over time as you run into weird errors, or as you realize that you need additional output from your shell scripts. You can just build on top of them, and it's good to write something very, very short, test it, add in some new functionality or a new command, and test it. So it's one of those things where if you just take a step back and build it in iterations, shell scripting is actually a lot easier than it's made out to be. So, Scott, what else should we add to our shell script? Or better yet, how about we talk about how can you run a shell script without having to be in that same directory?
Yeah, so I think what we want to look at first is the path environment variable for this user. I'm going to do an echo $path. And I see the problem. So 1 second, let me do one thing. Okay. So you'll recall from previous shows that there's like a little bit of weird environment setup for this box that I'm using as our example. And what I noticed and what I checked was the environment variable that tells the shell where to look for executable commands. And what was missing was this shell, which is where, or this directory, which is where I had put our shell script. So now that the path environment variable has the right content, right? If I run my script, tab completion works, it finds it just fine. And it turns out that this directory, your home directory and a subdirectory called /bin underneath of it, is standard to add to your path for bash shell logins for Red Hat Enterprise Linux. So you didn't notice because we started it that way, but here in my home directory, I created a bin subdirectory. And that's where our script is. And when we log in, it'll automatically check there for executables, in addition to places like user bin or user sbin on the system. And this gives a great way for individuals or administrators to create their own small commands to do stuff without having to add them to the system directories, which would then maybe grant access to all the people in the system to do that stuff.
So if we were to navigate to, say, var log, so that we weren't here in our home directory and we were elsewhere in the system, we should be able to type my script and myscript.sh and run our command again, and it would work. So having the scripts in one of those bin directories, a directory within our path, we can run it from anywhere within the system, which, like Scott said, is incredibly helpful as a systems administrator to have some of those customized command strings at our disposal, no matter where we're at in the system. So you used a feature within the terminal that we hadn't really talked much about. You did an echo $path, and what that is dollar path is known as a variable, and so anything with a dollar sign in front of it is a system variable. So I think a few of them are path. Obviously, I think shell is one of them.
We could get a list of all of them with the set command.
That's right.
So it shows us our included shell functions, but then up towards the top, oh, there's a lot of shell functions. Man, there's a lot of shell functions. Oh, and we've run out of rollback history. So how about I do a set less? Right, so there's our variables that we've got set.
Let's see. So yeah, if we do like a dollar sign bash, it would tell us that we're running the bash shell. If we did a dollar sign home, it would tell us where our home directory is.
Yeah,
And one
ones that sometimes are weird. Echo or rows. How many lines? That's what it is. So columns and lines are the settings for how large your terminal is. So that's how tools like less know how much of a file to display at a time on one page worth for your terminal. There's another one, PS1. That's what's displayed as your prompt. Although this one has a whole bunch of color coding in it, which is why I like that root at RHEL is green and the directory is blue, because it's got all these color codes embedded in my prompt variable.
which, by the way, comes by default in most bash shells these days, which makes it really easy to see what and where you're working. So how might this apply to our shell scripting example?
So one of the things that we can do in our shell scripting example, let's see. Well, first let's make a couple of slight tweaks.
So we're
Harkening
going
back
to
to our shows from just the other couple of days.
Yeah, so we're going to echo a blank line, and then we're going to tweak our IO stat like we did yesterday or the day before to just get some of the CPU information, and then another blank line.
All right. So here we're adding a prompt. Echo-n says don't print a new line after the query. So our cursor will be sitting just after the question mark space. And we're going to read a variable. Okay. So read is how we get data from the standard input, right, which would be somebody typing at the keyboard. And we're going to take that input that we get from the keyboard and store it in this variable reference. And then later on, we can use the content stored in this variable by referencing it with that $sign leading character. So when we say last, we see the $sign character, which says, they're going to reference a variable. So let me look up what's stored in the variable, and I'll substitute that on this command line. All right, so if I've done everything correctly, now when we run my script, we should see a little bit less IOStat data. We should see our free data. We'll see the date at the top, and then it should stop and ask me a question. And maybe I put in the RHEL user. And then it runs the last command, passing an argument of the RHEL user, and it looks like that person has never logged in. So let's change that. Oh, Well, that wouldn't work very well. And that's not going to work very well either. All right, let's see if that changed though. Script, RHEL user. Okay, so we still can't show them as a login shell. How about we do root? All right, so when we ask for the last login of root, it looks into the wtemp, which is a log file that tracks people's logins and is able to find the last login for that person that we passed in. All right, notice that my input is still a little bit messy, so let's go back in and I'll just put in a little bit of another blank line here and blank line there. And maybe we should clean it up a little bit more. Like, do we care that the wtemp belongs at this or started at this time? Or maybe we're just interested in this line, right? And that's where we can mix in some of the customizations that we saw over the last couple of days. So maybe we do a last query user, rep user query. So only show me the line that contains the string stored in this variable. Right, so now I don't get the wtemp start date in my output.
So you're starting to see how we can take all the tools in our toolbox and combine them together in different ways uh, to really help move forward with what we're trying to do. I mean, with just a few lines of code, uh, we've been able to get a date and time, CPU utilization, memory utilization, and to see what root has been doing and what root did in the last command that was inputted into the terminal. But one other thing we might try and do is, what if we wanted to pass a variable into our shell script? So a lot of the commands you see give like a tag and then an argument, or we pass if we're doing a user add, it requires an argument of what user do we want to add. Change mod, we had to tell it the permissions and the target for those permissions. So we can actually do that within our shell scripting as well.
Yeah, and so I will say that if you want to use options with the hyphens, that can be a lot more complex because there's a shell mechanism called getopt that will get options off the command line. So we're going to avoid that for now. We're just going to pass arguments. So what if I wanted to invoke my script like this? So that instead of having to type in at a prompt the user, I'm providing that as part of my invocation of the shell, and it should just run that command on that user. All right. So
That
let me go.
really helps with longer running commands where you may not need to sit there in front of your desk while the command runs. It's helpful to give that ahead of time and then be able to step away for a bit and then come back.
All right. So what I'm going to do is I'm going to add, and I'm going to do this in a kind of an obtuse way. Actually, you know what? Let's comment out all of our stuff that we put in there for querying that user. And how about we just last one? We could grab $1.
So you notice before we explain what the $1 is, I wanted to point out that notice that the old code is still there. It's just commented out. This is really helpful if you're troubleshooting or if something's not working right and you want to take a different approach. You can keep that old code there for as long as you'd like, and it really doesn't take up that much space. So you just comment it out. The interpreter will ignore that line, and you can always come back and add that functionality in later, or you can leave comments throughout your code. And one other thing I wanted to mention about the formatting of our script file is notice that the interpreter also ignores blank spaces. So we can format our script file pretty much however we want, adding spaces here, adding comments there, to make it very human readable. But our interpreter is not going to it's not going to see those new lines any different or those comment lines any different. It's ignored. So it really makes it easier to read through your script or someone else's script to see what they're trying to do.
All right, so I'm going to run this, and then we'll talk about what it's actually doing. All right, so my script, and we're passing an argument. Right, so notice that it still printed out the information about that person being logged in, but it didn't ask me for anything, right? So it turns out that when you pass a script arguments, each one of them is assigned into an automatic variable definition. So the first argument is $1, and the second argument is $2, and
What?
the third argument is $3, and so on, all the way until we've represented all the arguments. And then this guy right here, that's actually $0. So the script name itself or the program name is $0. So down here when I said run based off of $1 is the first argument that was passed to this script. But because we're making that choice based off of the first argument, if you're designing a script that has multiple arguments, now order is important, right? Because this command only runs on that very first argument as its operand. So if you mix up all of your things on the command line, we're going to pull the very first one, even if that's not the one you intended, because you told me in the script, use the first one at this point in our command.
So we're actually going to look. We've got a second episode planned, I believe, next week, to go in deeper into shell scripting, and we're going to add in if-then statements and loops. So we could actually, in that episode, we can come back to this example, and we can give it. We can give it a certain number of times to loop through a process, and that will allow us to handle multiple variables. But stay tuned next week for that one. So,
And,
Scott, is
and I
there
think,
any?
Eric, a good customization would be maybe we should do both things, right?
Mhm.
Check to see if there's an argument passed, and if so, just use it. But if not, ask us for the thing that is missing. So
Mm.
in that situation, we'll have to use an if statement to check to see what the state of the environment is like, and then choose to either just run last or prompt first and then run last.
So definitely stay tuned next week for that one. And shameless self plug next week, or I guess it's not a shameless plug, but good information to have. Next week we go to our regular show schedule. So next week we'll be live on Thursdays at 10 a.m. Eastern, and then is it 9 p.m. Eastern for dark mode?
That's correct.
Okay. So yeah, episode tomorrow. No episode tomorrow and dark mode tomorrow, but no episodes on Friday. And then next week we launch into our regular schedule. Um, so I think this is a first for End of the Terminal. We're sitting at 24 minutes and we got through all of our show notes. Do we want to do another example, Scott? Anything off the top of your head you can think of to share?
Sure, we can do a little bit. I would also leave it open to the uh, live viewers if they have questions, and if you're a deferred viewer, of course, you can put those in the comments of the episode, and Eric and I will get back to them. So I'll do one more example while they're thinking about their questions to ask live. Right? How about how do we store input from a command?
Hmm.
So here what we're doing is we're creating a variable called myUser, and we're assigning into that variable the output from this command whoami. So this dollar parenthesis um, syntax says, I want you to run this command and then take the output of this command and do something with it. It's called running in a subshell, or sometimes you'll see it referred to as quoted execution. And another way we could do the same thing, so I'll comment that out, is this. That's why it's called quoted execution. It uses the back quote. The reason I don't prefer to use back quote is because on some keyboards, specifically international keyboards, that back quote character is really hard to find.
Hmm.
So dollar parenthesis tends to be an easier combination for folks that don't use U.S. English keyboards to be able to get access to instead of back quote.
That's a great point.
So
I didn't ever realize that. But for our English using keyboards, um, yeah, it's also called a backtick or just a tick. If you're looking for that particular key on your keyboard, it usually sits to the left of the one key, and it is kind of a pain to get to, especially if you have small hands.
um, so I will down here at the bottom, we're going to print out a blank line, and then we're going to print the content that I stored in that myUser variable, which should be the output of a whoami. All right, so let's see what happens when we run the script. All right, so there's the output of that whoami command that I stored inside of that variable. Now, why this is important is we probably don't want to print it. Maybe we want to do something else with it, right? So let's see.
Well, Scott's typing. Eighth Doctor points out something that I didn't know in the chat here. He said that Bash, more accurately POSIX, deprecated backticks. So now the recommended method is the $sign parentheses. So don't worry about backticks. Just use dollar parentheses instead.
Okay, so I added a little bit of extra stuff. Notice that you can reference your variable inside of a string that you're wanting to print. So that'll substitute the content of the variable at this point in the output. And then I used it again in a different echo. And then here I'm using it as an argument to a command. So since I'm running the script as root, it should run groups on the root user, and we'll see what happens. Right, so it correctly substitutes here and here, and then it ran the groups command on the root user and printed the output of that groups command.
So as you can see, you can get really, really complex really fast. But the power that comes with shell scripts, the ability to repeat common tasks over and over and over again, is incredibly helpful. It reduces time, it reduces frustration, it reduces the possibility of human error. So there's just so much we can do with Bash scripts, and there's literally volumes and volumes of books written on the topic. But next Thursday, we'll also be able to we'll also get into for loops and if statements. So definitely tune in for that one. Tomorrow's episode, as we wrap up our launch series, tomorrow we're going to be talking about some patching practices. We'll get into live kernel patching. We'll talk a little bit more in depth about automatically scheduled patches, and a few practices. So tomorrow won't be quite as terminal heavy, but a little bit more best practice. And so definitely put your comments and your questions in the comments. We usually try and get back to those within a day or two. But for tomorrow's episode, please, by all means, let us know if you like some of the more practice-based episodes as well. Great, we learned how to use all these tools. Now, how does that look in a real-life scenario? So that being said, thank you all so much for joining us today. Be sure to like and subscribe, share it with a friend. We've gotten great feedback from people from 2 months working on Linux to 22 years working on Linux. So thank you so much for all the sharing and promotion you've been doing. Keep that up. And then join Scott tonight for Dark Mode as we start to wrap up our launch series. So until then, Scott, thank you so much for joining me today.
Thanks, Eric. Always a pleasure.
All right, y'all. We'll see you next time.